Section 4.6 is solving polynomial and rational equations and inequalities. This is very similar to section 3.5 when we did the quadratic inequalities. In fact, this first example and some of these notes are the same as that video. So if you need a little review, I would go back and re-watch that video. The biggest thing, especially with the rational ones, is making sure you're never canceling any factors. We've done this one before, so I'm not going to redo it, but remember we move everything over to one side, so one side is equal to 0. And then we factor completely and make a number line. Put anything that makes this 0 or undefined on the number line. So we have this first one, x to the fourth is greater than x. So again, our first step is always to make one side equal to 0 and then factor completely. So go ahead and pause the video and try that. Moved it over, I got x to the fourth minus x is greater than 0. I could factor out an x out of that, and I got x cubed minus 1. This is a difference of squareds. So linear terms squared together squared, and then same sign, opposite sign, always positive. Now we need to make our number line. We need to put anything that makes this 0 or undefined on our number line. There's nothing that makes this undefined, so we don't have to worry about that. This part right here is going to have complex zeros. So we also don't need to worry about that. We only care about real zeros. So our real zeros are going to be 0 and 1. And because this is strictly greater than, we're going to put open circles on these. They're not part of our solution. So now we want to test points to see whether these sections are positive or negative. So if I plug in something less than 0, like -1,000,000 is negative. If I plug in something like -1,000,000 into -1,000,000 minus 1, that's also going to be a negative. This section right here, this x squared plus x plus 1, is always going to be positive. The x squared is always positive, and that eats up that plus x, or if it's a fraction, that 1 will eat up that plus x. So that section's always going to be positive, so I have two negatives, which means this first part is positive. So go ahead and pause the video and try the next two sections. If I try something between 0 and 1, like a half is positive, so this first section is positive. A half minus 1 is negative, and then again, this is always positive. So I have an odd number of negatives, which means this middle part is negative. And this last section, you plug in something really, really positive, everything's going to be positive, so you have a plus. It won't always alternate, so just because this was a plus and this was a minus does not necessarily mean this is a plus, so just be careful. If we want what's strictly greater than 0, which sections do we want? We want the sections that are positive because positive numbers are bigger than 0. So our solution is negative infinity up to 0 not included, union 1 to infinity also not included. Here we have a rational inequality. Our first step again is always to make one side equal to 0. And then for a rational, we need to make a common denominator to simplify. So go ahead and pause the video and do that. So I move the 3 over, you get 4x plus 5 over x plus 2 minus 3 is greater than or equal to 0. And then I need a common denominator, so I multiplied this by an x plus 2 over x plus 2. So my common denominator was x plus 2. Make sure you distribute this negative 3 to both the x and to the 2, so you end up with negative 3x minus 6. And that simplifies down to x minus 1 over x plus 2. So now when you're making your number line, everything that makes this 0 or undefined. So basically anything that makes the numerator 0 or the denominator 0. 1 makes this function 0, it makes the numerator 0, and because this is a greater than or equal to, I'm going to put a closed circle on this. Negative 2 makes the denominator 0, so this makes it undefined, so I'm going to put that on my number line also. Because it is undefined, it is not in the domain, which means it can never be a closed circle. So if you have an undefined, it's always an open circle. No matter whether it's or equal to or not, it's always going to be an open circle. So now we want to test sections again, so go ahead and pause the video and find the answer to this inequality. So the first section is positive, you get a negative divided by a negative, then you have a negative, and then you have a positive. Because we want what's greater than, we want what sections are positive, so negative infinity up to negative 2 not included, union 1 included up to infinity. So here we have another inequality. One side is already equal to 0, so we don't need to worry about that. So go ahead and pause the video and factor this completely. So this factors into x squared times x plus 3 times x plus 4 over x plus 5 times x minus 1 is greater than or equal to 0. So now we need our number line with any points that make this 0 and undefined, being careful with whether they're open circles or closed circles. So go ahead and pause the video and do that. Test your points and find the solution to this inequality. So when you plot them, it should be -5, -4, -3, 0, and 1. 1 and 5 -5 make the denominator 0, so those should be open circles. Everything else makes the numerator 0, which we want, so those should be closed circles. This x squared is always going to be positive, so you don't really need to worry too much about that. That's always a positive no matter what. So then if you test points, you get 4 negatives, which is a positive, 3 negatives, which is a negative, 2 negatives, which is a positive, 1 negative, which is a negative. And here you can see it actually doesn't change. It doesn't switch signs because of this x squared. So it stays a negative and then it flips to a positive. Because we want what's greater than 0, you want the positives. So negatives infinity to -5 not included. Union -4 to -3 both included. We still want to include this 0. It's still part of the solution. There's two ways you can write that. Either set notation, so curly brackets with a 0, or just from 0 to 0 with brackets, and then union 1 to infinity not included. So make sure whatever makes the numerator and the denominator 0 goes on your number line. Never cancel factors, don't divide by x or anything like that. And then make sure you're careful with your open circles and your closed circles and what's positive and what's negative.